We are going to talk about the phenomena of photoelectric effect, which is having a photoelectric current from the metal surface. So let's first understand that how we can have photoelectric current from metal surface. So let's assume that we have a metal surface and electrons are distributed all over the surface, and we have the source of electromagnetic radiations, and we make the electromagnetic radiations fall upon the metal surface, and we have also connected this metal surface into a circuit where there is an ammeter in order to measure for us the current. So what happens when these radiations fall upon the metal surface, that we get the photoelectrons. But there is a problem with this experimental observation, which is precisely is the following, that photoelectric current is actually a frequency dependent. What does this mean? In order to understand this, assume that this metal surface is actually a silver metal, and we fall upon it the visible red color light, and what we expect that we should have electrons moving over here, but what we get is that there is no current. We think that probably the reason for not having the, current is the intensity is very low. So why not to increase the intensity? And when we increase the intensity, even double it, what we get, that again there is no current. And even if we increase it more and add another source, we still don't get a current. And we think further and we say, why not to change the frequency of these electromagnetic radiations, and we change it, and we bring in the source of X-rays, and when we fall upon it on the metal surface, which is made of silver, what we get is the current. Now this is a disturbing phenomena, because the photoelectric current depends upon the frequency and not intensity, precisely saying that why higher intensity of low frequency electromagnetic waves does not knock off electrons, or in other words, we get photoelectric current for X-rays and not for the visible light, even though the intensity of X-rays is way less than the intensity of the red color. But wait, we know one thing, that the frequency of the X-rays is greater than the frequency of red color light, and Einstein actually proposed that this all the electromagnetic radiations are made of packets, and one packet has energy equal to this E is equal to hf. But this was given even before Einstein by Planck, and then why not Planck was able to explain the photoelectric effect? The reason is the following. We compare both scientists and their hypothesis. Planck actually said that in the black body radiations, the electromagnetic radiations which fall upon the black body are actually continuous and not discrete or quantized. Then something happens inside this black body, something peculiar property of the material, and when it emits after absorbing the radiations, it emits into the packets of the energy and not the continuous radiations. But Einstein went further and he said that no, actually these radiation by themselves are made of the packets. And with this assumption, he was able to explain the phenomena of photoelectric effect. But going to the explanation, let us make some simple calculations. For example, for the red color, we want to calculate the energy of a single photon, and you can see this frequency and wavelength, and if you calculate, you get the energy of photon equal to 2 electron volt, and we have used this relationship over here as well. But when we calculate the frequency of the energy of the X-rays, soft X-rays, we get the energy equal to 1.24 kilo electron, which is way more higher than the energy of the red color photon. Now let's go back to the metal surface and see, for example, select the silver metal and see what happens there. When we zoom in there, we see that electron is actually bounded to the nucleus, and the binding energy is called the work function is 4.64 for the silver metal. And what happens when we have a red color whose single photon is having energy 2 electron volts, comes here and strikes the electron. After the collision, it is not able to knock it off. The reason is very clear, that the energy is less than the energy of the work function. Even though we increase the intensity, you will not be able to eject this electron, because single photon strikes the electron at single time. But when we change the frequency and we bring in the soft X-rays, the single photon having energy 1.2 kilo electron volt is able to knock off this electron because its energy is greater than the work function. So by this way, Einstein was able to explain the phenomena of photoelectric effect, and that why electrons are knocked off with the electromagnetic radiations whose frequency is high but intensity is low. Thank you very much.